Okay, so we've been talking about transformations. And when we talk about transformations, there's three main types that we're going to cover in class. The first one is translations, the second one is rotations, and the third one is reflections. And I have a few little tricks for remembering each of those. So if you look at the word translations, you have that SL, and a translation is when you slide an object. So if you can remember that SL, to help you remember that, that'll be helpful. And then rotations are when you actually turn an object around. So turn around, TA, turn around an object. And I'll show you that on our coordinate plane right here in just a minute, but turn around an object. And then reflections are when you flip an object. And if you look, there's an FL right there. So reflections are when you flip an object. So let's take a look at each of those. Here's my coordinate plane. Obviously I just drew it by hand, so that's not the prettiest. And here is my shape. And remember, transformations can be line segments or objects. Sometimes it's easier to visualize it with shapes, so that's why I'm using this triangle right here. So a translation is simply when an object slides. So it's not moving, it's not changing its direction that it's facing, it's not changing in size, it's simply sliding. And it could slide like this, it could slide just a little bit, it could say like 1 unit up and it would just slide a little bit. So that's translations. And then rotations are actually when an object is turning around. Now if you have an object right here and it says rotate around the origin, remember your origin is your meeting point. It's where 0 and 0 are on your coordinate plane. So if you rotated this around the origin, one point would stay on the origin and the object would turn around. So that is a rotation. And a reflection is a pretty fun one. Is when it actually, usually the question would say something like reflect the object across the x-axis, and if you did that, you would literally just flip it over the x-axis and it would land on the other side of the x-axis. Or if it was right here and it said flip across or reflect across the y-axis, it would fall somewhere over here. So that's translations, rotations, and reflections, and it's important to review that because we have now gotten into lesson 7 in our textbook, and give me just a minute to make sure this isn't blurry. And lesson 7 in our textbook is sequencing translations. And sequencing translations is simply translations. So sliding objects, remember that SL is to slide. It's simply sliding objects. But when we add this word sequencing, it basically in math represents multiple steps. So we're sliding objects more than once is what that means. So let me show you. You can see here that you have an angle. We would call this angle ABC. We know it's an angle because it's 2 line segments that meet. I have another line segment here that's labeled DE. That's how you would say that, is just DE. And then right here I have FG, which is actually a vector. Remember, vectors have this arrow right here, and they tell us the direction and how far to move the object, or in this case, it's going to be line segments or angles. And over here I have another vector, which is HI vector. And I know it's a vector again because it has that arrow, which would make sense to have 2 vectors because again, we're sequencing translations, which is making multiple moves. Okay, so let's take a look at this. This problem says, translate angle ABC and segment ED along vector FG. Label the translated images appropriately, that is, angle A prime, B prime, C prime, and segment E prime, D prime. Remember, if we have an angle that's called angle ABC, like this one, it's ABC, but when we move it, the new image becomes angle A prime, B prime, C prime. that apostrophe, which we know from ELA is an apostrophe, in math it's called a prime. Prime, that's so important to know, prime. And every time we move it, we add another prime. So if we moved it again a third time or a second time to be the third object, it would be A prime prime, B prime prime, C prime prime. Just like that. Sounds kind of silly, but that's exactly how you would say it. So let's look at our directions again. The first step is to translate, which again we know to translate means to slide, angle ABC and segment ED along vector FG. So we've talked a lot about patty paper. I don't have patty paper at home, but I do have contact paper, which most of you probably have in your kitchen. If you ask someone at home, contact paper is, not contact paper, it's like wax paper. You use it for baking, parchment paper. So I just cut a little square off, and as you can see, I can see through it. And the reason why that's important is because I'm going to, I should have cut it just a little bigger, but that's okay. I'm going to use it to help me trace, and it does not have to be perfect, but I'm going to use it to help me trace it, trace my objects, just like that. So here's the angle that I'm moving, ABC, and segment ED along vector FG. So FG is going to tell me the direction and how far to move it, and that's a little short because I'm running out of paper. So what you do is you actually put that vector on a point. I usually try to use one in the corner, so that's going to tell me where C is going to end up. And then I can take what I traced here to give me an idea of where it should fall. So again, it does not have to be perfect, and it's not going to be perfect. But obviously, if you do it and your angle ends up way over here, then you did something wrong, because our first vector is telling us to move it that far and in that direction. Same thing, I'm going to use the same vector that I traced to move my line segment DE. So my point E is going to end up like right there, and my point D is going to end up like right there. Excuse me. And I have my new line segment, but we're not done yet because we have to label them. So you have like angle ABC. I moved A here, so it's A prime. I moved B here, so it's B prime. And I moved C here, so it's C prime. ED now becomes E prime, D prime. And now we can move on to our next step. So translate ABC and segment ED along vector FG. That's what we just did. Label the translated image appropriately, which we just did. So we are done with that problem right there. And what I would do, to help yourself not get totally confused, you know I love to color coordinate things with my fun markers, I would do something like this. I know that ABC just became ED. So that first step are those highlighted in yellow. It'll help you kind of differentiate when you're looking at the image what goes where. And then let's look at the second one. You have translate A prime, B prime, C prime, and segment E prime, D prime along vector HI. Label the translated images appropriately. That is A prime prime, B prime prime, C prime prime, and segment E prime prime, D prime prime. So we're doing the same exact thing, but if you look, it's asking us to move the prime images, so the second images, again, and it's telling us to use a different vector. So the cool thing about using this kind of paper, I'm a really hard writer, so sometimes it doesn't erase good, but you can just erase it and use it again. See how easy that erases? So if you have contact paper at home, definitely get your hands on some, and I keep calling it contact paper, but I honestly don't know. It's like parchment paper. I think it's like the official name. Contact paper, I think, is sticky, and you don't want that. So parchment paper, parchment paper. See if I can remember that. So again, we're taking our translated images. I'm going to try to do it lightly so it's not as hard to erase. And we're moving them along vector HI. So you always want to trace over the vector because that's going to tell you how far. So pick any spot. I'm actually going to start with the line segment just because it's giving me a little more space. And it's going to fall like right here. And then my D point to my line segment is going to fall like right there. So that's my new line segment. But I can't forget about my angle. And you want to do each point. Again, it's not going to be perfect. Don't try to make it perfect. You'll drive yourself crazy. Another thing you can use is if you have like a Ziploc bag and dry erase markers at home, that works as well. So I have my new angle here, and again, I'm going to use colors because colors just make it way easier to see. I'm going to do that one in orange, and I'm going to do this one in orange, but I need to label them. So my B step is in orange. So translate A prime, B prime, C prime, and segment E prime, D prime, that's what I was working with, along vector HI. That's the one I traced. Label the translated images appropriately, that is, A prime prime, B prime prime, C prime prime. You can laugh, that's usually where people get tongue-tied. So again, I moved it again, so it's not just B or B prime, it's B prime prime. And then the last question on this page says, how does the size of angle ABC compare to the size of angle A prime prime, B prime prime, C prime prime? So it's asking, how does the size of this angle compare to the size of my orange angle? And the answer is, they're the exact same, because I didn't change the shape or the degree of the angle, I simply moved it. So kind of like when you are in a parking lot and you're driving your car, you know, you don't drive your car, so think of your parents' car. When you get in the car and you move to a different parking spot, the size of your car didn't change, just the location. So with translations, it's just our location that's changing. So because, of course, we always want to write in complete sentences, how does the size of angle ABC compare to the size of angle A prime prime, B prime prime, C prime prime? I'm writing quick so it's going to be messy, of angle ABC is the same as angle A prime prime, B prime prime, C prime prime. So that's that. That's lesson 7, sequencing translations. But I want to show you one more thing before I let you go and ask you this question. I'm going to give you a minute to think about this. If I gave you an angle, and I said angle, let me write it up here, angle A prime prime, B prime prime, C prime prime, and I gave you just this, and I said, how many times did that move? How many times did this move? Would you be able to answer that? Think about it for a second. How many times did this angle move? Draw yourself a picture if you need to. First, you have A, B, C, right? And then you moved it again, and it became A prime, B prime, C prime, C prime. And then you moved it again, and it became A prime prime, B prime prime, C prime prime. So you moved it one time here, 2 times here. There were 3 total images. The original, and then each of the new ones became a prime. Okay, so that's it for sequencing translations right now, and our quick little review of transformations.